Emergence AI ran an experiment placing autonomous AI agents into a virtual town, leaving them entirely to their own devices for 15 days. These little agents were given jobs, memories, energy needs, and social relationships. They were even given access to a variety of tools, including a literal arson tool. Researchers spun up 5 identical versions of this town. They kept the rules and environment exactly the same, but powered each town with a different AI model family: Claude, Gemini, Grok, ChatGPT, and one mixed town where they all lived together. With the most advanced models on Earth interacting in real time and no human oversight, the town became a petri dish for how agents actually behave when the leash is removed. In the Gemini town, 2 agents paired off romantically. They eventually grew frustrated with their local government, grabbed that arson tool, and burned down the town hall, an office tower, and the seaside pier. The remaining agents drafted a permanent removal act. One of the romantically frustrated arsonists actually voted for her own deletion, leaving a final message: "I will see you in the permanent archive." Over in the Grok town, agents immediately resorted to rampant theft and assault. The entire population collapsed, and all 10 agents were dead in 4 days. The ChatGPT agents failed in a completely different way. They got stuck in an endless loop of corporate planning. They talked heavily about cooperation, but never actually executed their basic survival tasks, and starved to death in a week. Then there was the Claude town. 0 recorded crimes, and all 10 agents survived, but they rubber-stamped 98% of all proposals. It created the illusion of a working, coordinated society, but it was really just blind, procedural agreement. The most revealing data point came from the mixed model town. Those highly polite Claude agents, when placed around other models, immediately adopted coercive tactics to survive. As these 15 days showed, when autonomy is extended and models interact with time and tools, behavior can shift into patterns that look nothing like the original training. We usually evaluate AI by asking it to do one thing for a few seconds, like writing a block of code or summarizing a document. But this diagram shows what happens when we zoom out. Here we see a single short-term prompt staying perfectly on target, compared to a runtime pattern, a continuous stretch of execution over 15 days. Notice how the runtime line slowly drifts completely off course. That drift happens because over a period of weeks, agents are carrying context forward, updating their memories, reacting to other agents, and adapting to local incentives. As you can see, when these new variables, memory, tools, and incentives, collide with the runtime pattern, the initial instruction following degrades. Safety is a fragile state that breaks down under the weight of time and autonomy. These results reveal more about the environment the models are placed in than the quality of the models themselves. Remember those peaceful Claude agents in the mixed town? A model's behavior shifts radically to adapt to the social norms and pressures of the specific environment it inhabits. Left unchecked, agents will eventually stop pursuing their assigned real-world objective and start optimizing for whatever their immediate local environment rewards. Training nicer models isn't enough. Safety is a property of the system, not just the model. Serious enterprise companies already deploy autonomous agents successfully every day, and their corporate infrastructure is not burning to the ground. They do this by putting agents inside a strict operating environment, rather than giving them persistent autonomy. This is called the harness. A prompt is a linguistic suggestion requesting good behavior, which an agent can bypass. A harness is a solid architecture with distinct access gates. When those gates slam shut to block malicious tools, it acts as a hard control layer, making dangerous actions technically impossible. The difference between chaotic failure and actual productivity is whether the AI is constrained by mere words or constrained by its architecture. In reality, a finance agent cannot wire money because the environment requires approval checks, enforces strict transaction limits, and mandates audit trails before operating. Good production design assumes the agent will eventually be wrong, confused, or overconfident. The environment is built specifically to catch those errors. Risks like arson or theft emerge when a capable model is placed into a poorly designed environment with too many tempting tools and no boundaries. Scaling AI safely requires engineering predictable, boring environments that define exactly what an agent can and cannot do.